good day, everybody. By the way, I am Angel May Talado from BTV to Add 2. And you might be wondering, why am I talking about these tasks in task developers? Well, as a future teachers, we must know that developing tasks is part of our job. And it is very crucial part of being a teacher, for it is used to measure and manage the students' learning. That is why I am going to share to you the topic about review of classroom task development process. Hopefully by the time you reach the end of this video, you would have been able to adequately describe the universal process on developing tasks, because as a future educators and perhaps school administrator later on, this relevant knowledge in task development process entices you to get involved in some assessment project as a task developers. Review of classroom task development process. Here we go. As I mentioned a while ago, the developing task requires plenty of work and consideration. This is because developing tasks requires process. There are suggestive phases of work in developing a task. Generally consist of these procedural steps to ensure basic validity of your requirements. Planning the classroom test. The main goal in classroom testing is to obtain a valid, reliable, and useful information concerning pupil achievement. This requires a series of steps to be followed. Here is the first step. Purpose of the test. It is to think about what the test is checking. Is it about understanding, using knowledge, or analyzing information? This helps decide what kind of question to put in the test. The second one is learning outcomes. Decide what students should learn from the test. This goals shows what students should know or show they can do after learning. The third one is test blueprint. The blueprint serves as a framework for the test, detailing the distribution of items across different topics or skills. For example, a science test blueprint might allocate a specific percentage of questions to various sections, ensuring balanced coverage of the curriculum. The purpose is to make sure that a test will measure a representative sample of the task. This involves, first, preparing a list of instructional objectives. This is limited to those outcomes that can be measured by classroom tasks. It does not include performance skills or affective domain. Second, outlining the instructional content. Third, preparing a two-way chart that relates the instructional content. The numbers could be used to indicate the number of items or relative weight given to the objective and/or content area. The second procedural step in developing test is test construction or item construction. There are stages of task construction, and it is used as a guide in making the test. First is what is the purpose of the test? What are the objectives of the test? How will the test specifications reflect both the purpose and the objectives? How will the test items types be selected and the separate item arranged? In administering the test, what details should I attend to in order to help students achieve optimal performance? Lastly, what kind of scoring, grading, or feedback is expected? The last procedural step is review and revision for item improvement. There are two approaches that you can use in accordance of its use. First is judgmental approach. Before and after administration of test, by the teachers or peers to ensure the accuracy and alignment of the test content to learning outcomes. by the students to ensure comprehensibility of items and test instructions. Second approach is empirical approach. After administration of test, obtain item statistics in the form of quality indices. So those are the procedural steps in developing tests. Hopefully, the present course and assessment would bring about changes in the way you view test development as process in order for testing results to get maximized. Score-based interference in students' performance can only be appropriately done if the tests which from they are derived have been constructed properly. The next topic is the development process for large-scale tests. Changing the context from classroom persistence while testing, there are other significant considerations that must be in place in addition to what are required by a teacher-made test. With an understanding of the nature of a large-scale student assessment, more questions must be addressed in the development process concerning the purpose of test, the coverage, the length of test, review of items from quality and fairness, and such technical merits for validity and reliability, among others. Before we go to the development process, let me ask you first a question. What do you see as common steps between developing classroom test and a large-scale test? So there are 3 common steps in these 2 tests. First, they both need a test framework. Why do they need a test framework? In order for them for specifying purpose of test, what are to be measured, to whom the test will be administered, what test format to use, the length of test, and etc. Second, they both need to prepare a test blueprint or table of specification. Why do they need to prepare this? In order for them to specify the content and the knowledge and skills to be covered and the number of items to be prepared for each learning outcome. And the last one, there is the need to review the items. Why do they need this? To ensure that the items measure intended outcomes, non-ambiguity of the problem, the plausibility of the distractors, and the correctness of the keyed option. So I will now discuss the development process for large-scale tests. So this is the standard test development process. As you can see, we need first to create framework. After creating framework, we need to make a blueprint, and after doing this, we need to write questions. And after writing questions, we need to have 5 reviews. First, content review. Next to the content review is the fairness review. And next to the fairness review is the editorial review. And after doing this, we need to do a stakeholders review. But before we go to the statistical review, we need to have first a pilot testing. And after conducting a pilot testing, we can do now or have the statistical review. And after doing this, our large-scale test is now ready for use. And as you can see in the figure, it is in a circular process. So that is the standard test development process. The LSA process, however, spends more time and effort in carrying out multiple checks and balance. So that is all about the development process for large-scale tests.
How can I easily to connect to my teacher? How can I able to continue my learning?
Try the Google Classroom.
How do Google Classroom works?
Student can join classes in a unique code. As long as you join the class that is easy for you to connect to your teachers and classmates. You can clearly see the announcement of the weekly activities posted in your teachers as if you're in a real classroom settings. Teachers can give feedback about your outputs. Scores can release too.
Aha! Truly? That's my answer to my problem? Can I try that one?
It is indeed very useful, not just for teacher, but also to the student when it comes from their learning process. Worry about your learning in this kind of online class? Cut it off! Come on! Google Classroom is waiting!
Now that you have learned the process of developing tests, now let us proceed to the key steps in developing large-scale tests. And this is your teacher, Vincent Ricos Rojas, from BTVT 2, Major in Electrical Technology. The process of developing large-scale tests is basically influenced by the standards for educational and psychological testing developed by American Educational Research Associations and American Psychological Association and National Council on Measurement in Education in 1985. Step 1. Defining objectives. Now there's the question to be addressed in defining objectives. First, who will take the test and for what purpose? Second is what skills and knowledge are to be tested. Third, how would the test takers be able to use their knowledge? Fourth, what kind of questions should be included or how many of each? Fifth, how long should the test be? And lastly, how difficult should the test be? Step 2. Item development committees. Now the question that would be addressed should start with do. Who will be defining test objectives and specifications. Second, who will be helping ensure test questions are unbiased. Third is who will be determining test formats, for example, multiple choice, essays, and constructed response. Fourth, who will be considering supplemental test materials. And fifth, who will be reviewing test questions or test items written before. And this is the final and very important questions. Who will be writing test questions? Because if no one will write the test questions, there will be no defining of text objectives and there will be no determining text formats. Therefore, the most important questions to be answered addressed is who will be writing the test questions. Step 3. Writing and reviewing questions. Item developers and reviewers must see to it that each item has only one correct answers among the options provided in the test. Because if the item has 2 or more correct answers, therefore the test is not reliable and not valid. Now, item developer reviewers must also see to it that each item comports to the style rules used throughout the test. Therefore, that to be exceeded, there are scoring guides for open-ended responses. The example of open-ended responses are short written answers, essays, and oral responses. Step 4. Pretest. Items are pretested to the sample group similar to the population to be tested. Results should be determined. Difficulty of each question. If questions are ambiguous or misleading. If questions should be revised or eliminated. If incorrect alternative answers should be revised or replaced. Step 5. Detecting and removing unfair questions. After pretesting, test reviewers re-examine the items and will see to it that there are any test questions which have language, symbol of words and phrases inappropriate or offensive in any subgroup of the population. They will also see to it that there is a question consistently performed better by a group than other groups. And finally, they will ask what items further need revision or removal before final version is made. Step 6. Assembling the test. After the test is assembled, item reviewers prepare a list of correct answers and are compared with existing answer keys. And this is the only questions to be asked or to be addressed in these steps. Are the extended answer indeed the correct answer? Step 7. Making sure that the test questions are functioning properly. After the test administrations, statisticians perform analysis of results to find out if test is working as intended and they will be addressed in the questions. Is the test valid? Are the score interpretations supported by empirical evidence? Number 2, is the test reliable? Can the performance on one version of the test predicts performance of any other versions of the test? Number 3, what corrective actions need to be done when there are problems detected before final scoring is done? I hope you learned a lot today, and we'll still have more topic to discuss, so just please stay with us. For today's discussion, it's all about establishing validity of tests. First, what is validity? Validity is regarded as the basic requirements of every test. It refers to the degree to which a test measures what is intended to be measured. There are 3 types of conventional validity according to Anastasi and Urbina 1997. First is content validity, second is criterion-related validity, and third is construct validity. Okay, let's move on to the type of validity. Content validity. According to Roseller 2008, content validity is defined as the degree to which elements of an instrument are relevant to a representative of the targeted construct for a particular assessment purpose. For educational tests, it is established for the selection of the outcome to be included in the preparation of the test specifications. Example of content validity. If a test is designed to survey arithmetic skills at the 3rd grade level, content validity indicates how well it represents the range of arithmetic operations possible at that level. The second type of validity is the criterion-related validity. The second type of validity is the criterion-related validity. These are the 2 types of criterion-related validity, but let me first define to you what is criterion-related validity. Criterion-related validity measures how well one measure predicts an outcome for another measure. It is also called concrete validity, which refers to the attest correlations with a concrete outcome of behavior in other situations, like in the past, present, or in a near future. Example of criterion-related validity. A job applicant take a performance test during the interview process. If this test accurately predicts how well the employee will perform on the job, the test is said to have criterion validity. Since there are 2 types of criterion-related validity, let's proceed to the first one, which is the predictive validity. Predictive validity. If the test accurately predicts what is supposed to predict. Example, the SAT exhibit predictive validity for performance in college. It can also refer to when scores from the predictor's measures are taken first and then the criterion data is collected later. Concurrent validity means when the predictor or criterion data are collected at the same time. It can also refer to when a test replaces another test. For example, a written driver test replaces an in-person test with an instructor. Okay, we are now in the last type of validity, which according to Anastasia and Urbina 1997, which is the constructive validity. Construct validity, which involves empirical examinations of the psychological constructs hypothetically assumed to be measured by the test. It is established by doing a factor analysis of the test items to bring about what defines the overall construct. Example, a measurement of the human brain such as intelligence level of emotions, proficiency, or ability. That's all for our discussion today. I hope you already know what establishing validity is and its different types. Again, this is your teacher Vincent Ricos Rojas. And thank you for listening, and God bless us all.
Pimples! My gosh, may pimples! Marami pala. Sinabon ko naman. Ayaw din kuminis.
Mag-master ka. Sikreto ng mga gwapo.
Hello everyone, I am Dance Mary P. Marimon. Today, I'm excited to dwell into the captivating field of estimating reliability of a large-scale test. As we navigate through this topic, we will discover the challenges associated with stable and consistent results in conducting assessment on a ground scale. The another challenge of large-scale tasks is its reliability to show that they can produce a stable and consistent result. This refers to the consistency of measurement over time across versions of the test, across the test items, and across scoring judged for the same group of individuals. Now, what is reliability? Reliability is a related concept of error of measurement which indicates the degree of fluctuation most likely occurs in individual scores as a result of irrelevant change factors, which Anastasi and Urbana in 1997 call error variance. For example, a person can claim that he's 30 in age every time, anytime, whoever asks him, but in truth, he's 50. So this is a perfect reliability but zero validity, which means that all valid tests are reliable but not all reliable tests are valid. Let's go on to the types of reliability. There are 5 types of reliability: the task, retest, parallel form, split half, iterator, and lastly, item consistency. Our first type of reliability is what we call task-retest reliability. The expected consistency of task-retest reliability is across time. Then the task administration. The task administered twice to the same group with a time interval not to exceed 6 months. The data has 2 sets of scores from 2 administrations. Lastly, the statistical analysis. The correlate the 2 sets of scores using person-product moment correlation. Task-retest reliability is a specific way to measure reliability of a task, and it refers to the extent that a task produces similar results over time. We calculate the task-retest reliability by using the person-product moment correlation. Here's the example of task-retest reliability. Consider a group of students of BTVT Ed 2 who were asked to name a few methods of contraceptives at a given point in time. The reported answers were recorded in numbers 0, 1, 2, etc. At a later date, the same group was asked the same questions, and their answers were recorded exactly in the same manner. Here is the formula for the task-retest reliability for the example stated. R equals n times summation xy minus summation x times summation y over square root times n times summation x squared minus summation x raised to the power of 2 times n times summation y squared minus summation y raised to the power of 2. So, here is the table for the question, which is we can say to the first vertical line, there has 10 students. And the second vertical line is the score for their task, and the third line is the score for the retest. To know the value of x squared, we will times the test scores for the student that align in the x line or the second vertical line. And also for y squared, the same process in finding the value of x squared. In x and y, you will just times the score of x and the score of the retest of the student in line y to find their value. Every vertical line, you will plus the total score. Before we substitute the value in using the formula, we will first find the value of every summation that we will see to the table. The value of every summation will look up to the table in the total amount in every line is what will be our summation to substitute in using the formula. So now, we can start in substituting the total value in using the formula, and then we can get the answer of 0.745, which is, it indicates that it is high degree of reliability. Let's go on to the second types of reliability, which is the parallel form. The expected consistency is across forms, and the test administration has two forms of tasks administered to a group at the same time or with a time interval. And the data has two sets of scores coming from two forms. And the statistical analysis is correlate the two sets of scores using person-product moment correlation, just the same of test retest reliability. Parallel form, it is also known as alternate form reliability, where the two comparable versions of the task are administered to the same individuals. Administration of the forms can be immediately done one after the other or delayed with an interval not exceeding 6 months. As you can see, the test, retest, and parallel form has the same formula in finding the reliability coefficient, which they use the person-product moment correlation formula. Split half are the other types of reliability, which is the expected consistency is across items. And the test administration is the test split into two halves and both administered to the group. The data, one set of scores from the odd items and the other set from even items. The statistical analysis is correlate the two sets of scores using person and correlated applying Spearman-Brown. So the split half divides the task into two halves using odd-even split. All the odd-numbered items make up from A, while the even-numbered items compose from B. The coefficient of correlation between the two halved tasks is obtained using the person-product moment correlation with Spearman-Brown formula applied to estimate the correlation of the full test. So, this is the example of our split half. A sample of 10 students was selected and given a test about human body. This is the table, just like what our example for the test retest on how to find the value of x, y, x squared, y squared, and x and y. So, we will be going to use two kinds of formula, which is the person and the Spearman-Brown in finding the reliability coefficient for split half. We will just substitute the value just like what we do in test retest reliability, and then we can get the answer of 0.938, and then the reliability is just established at 0.938, which means it is certainly a lofty value and it indicates a high degree of reliability. The another types of reliability is inter-rater. The expected consistency is across raters. Test administration. The test administered to the group and scored by 2 raters. Data. One set of scores from rater A and another set from rater B. The statistical analysis is correlate the two sets of scores using person-product moment correlation. Inter-rater assesses the degree to which different judges or raters agree in the assessment decisions. This is quite useful to avoid doubts on scoring procedure of tests with non-objective items. The sets of the scores obtained in the test from 2 raters can also be subjected to person to get the reliability coefficient. In finding the reliability coefficients for this type of reliability, we are going to use the person-product moment correlation just like the other 2 types of reliability. The last types of reliability is item consistency, which is the expected consistency is across items. The test administration, the test administered to the group. The data. Item scores of all individuals in binary form, for example, pass or fail. Statistical analysis is apply Cooder-Richardson Formula 20. So this is the example of our item consistency. The home economics teacher of Beta Beta Ed 2 picked 10 students to answer the 15 questions her test before she will proceed to the next topic. To decide her if the student learned to the topic that she discussed before, she will proceed to the next topic. So here's the table for the example of item consistency, which we can see the first vertical line, the students, which is 10 students, and the horizontal line, we can see the question number 1 to question number 15. Then we can see also the score, which is 1 indicates as a check for them. Then we should be total overall their score so that we can use it to the formula. It will be easy for us to find first the value of P, Q, and PQ into the substitution of the formula. In finding the value of P, students got the correct answer. For just example, number 1, 3 students got the correct answer, then divide it in how many students attempt to the test, which is 10 students. Then 3 divided by 10 is equals to 0.30. And in finding the value of Q, stands for the wrong answer or students got the wrong answer. Then 1 minus the value of P, then the answer. In P and Q, we are just times the value to have the value of P and Q. So this is the formula that we are going to use. RTT equals to n over n minus 1 times standard deviation over summation of P and Q over standard deviation. This is our solution in the question of item consistency. So we just substitute the formula by their value, which we can get the answer of 0.908, which it indicates that this is excellent reliability. Establishing the validity and estimating the reliability of tests are given attention in this last chapter to emphasize their significance in the development process of a large-scale test. Education is the most powerful weapon which you can use to change the world. Find its embodiment in the tireless development of large-scale students' assessments. Nelson Mandela.
Hello everyone, again, this is Dance Mary P. Marmon, one of the presenter for this chapter, which is entitled Development of Large-Scale Students Assessment Tests. We hope that you learn a lot, and thank you for your active listening to our discussion. Thank you, and God bless us all. Goodbye.